Right. So I've got one slide and one prop. Avtar, my colleague, has rather more props, which I'm surrounded with here. Actually, you'll see them more later. What we're trying to do is kind of, I suppose, in a way, broaden the discussion beyond the normal, as in, climate change caused by emissions. Emissions come from cars, come from aircraft, and so on. Absolutely, yes. But I just wanted people to be aware of the implications of everything, really. I mean, everything, in terms of what we use in our normal society today. So try and broaden the awareness, in effect, in the context especially of resources and waste and implications for, of course, climate change. I'll then hand over to my colleague Avtar, who's going to talk about the kind of opportunities, the new research that could lead to ways around some of the problems I'll address. So I'm talking really about, so this is a prop I use all the time, and it's meant to be just a collection of things, items that everybody knows about, and on the hook, probably most people here certainly have clothes, obviously. They will eat food, I'm sure. They will use personal care products. They will use electronics. They will take pharmaceuticals occasionally. They will possibly be in cars, their own or somebody else's, etc., etc. What you're sitting on, what you're wearing, what your feet are on at the moment, all of these things, of course, have implications for environmental impact, fundamentally because of the resource implications and also because of the waste implications. So I'm not saying we should stop using them. In fact, one of the big issues I think we face at the moment is trying to decouple resource consumption from growth, because people tend to talk about growth as therefore equaling more and more resource consumption. And when I say resource consumption, I mean resource consumption in a way that stops us getting the resource back again. So very much the linear economy. And you can take any one of the things I've got there as an example. So you take, even the least controversial in some respects, like pharmaceuticals, only 1% efficiency. About 1% of what goes into a pharmaceutical company ends up in a pharmaceutical product. Now, you may well say, well, it's kind of worth the risk, worth the waste, if you like, because they're so important for us, absolutely. But maybe we should think more about the 99% of other stuff that we currently don't valorize, to use that rather odd English word. And the same applies across all things. What you're sitting on, the furniture. The furniture is a product of the chemical industry. I'm a chemist, I'm very proud of it. And it's a good example of actually where we've taken a whole bundle of resources, mostly fossil resources, mostly petroleum, and used chemistry to turn them into something much more valuable that goes into, for example, a chair. So we take a chair, where you're sitting on at the moment, and the chair's got a mixture of synthetic and possibly some natural components as well. A lot of synthetic stuff, the plastic in there, the various additives in the plastic, they are made from chemicals. They're mostly made from fossil, typically from petroleum. So they have a resource implication, and that resource, of course, is becoming more and more of a concern. People say we're running out of petroleum. Not necessarily. Okay, we will do, of course, eventually, but it's more to do with where we get the petroleum from. We get more and more petroleum from more and more difficult places. So future petroleum is going to get more and more difficult. The Gulf of Mexico was a sign of things to come. I know people in BP who admitted that. This will happen more and more. We'll go look for more and more difficult petroleum to try and stay the same as we are. And I think one of our fundamental arguments, myself, Avtar, on the green chemistry team, is we need to change our philosophy about where we are today and recognise the fact this is the time to change. So petroleum is running out. It's getting more and more difficult environmentally and economically to extract. And also people aren't investing. The amount of investment in new oil is the lowest ever. So people are getting the message on the whole, but it still continues to be a fundamental part of our society. We're using crude oil to basically, for example, to make polymers, and the polymers then go into the plastics. The plastics we all know about now, you're sitting on, to some extent you're wearing, we have around us, all around us. And this applies everywhere you look. There are implications, resource implications, typically based on non-renewable resources. Processing implications that I won't have time to go into today, which is the chemistry, the conversion of those resources into useful stuff, and very importantly, what we do after we've used the chair you're sitting on, the clothes you're wearing, the car you're driving, and what happens to those resources after you've finished with them. And that's where we get into the world of the transformation, if you like, of going from the linear economy I talked about before, where you dig something out of the ground, get it out of the ground, you process it, and then you use it, and then you dump it, typically at a landfill site, or burn it, or even worse, lose it into the environment like plastic waste. And, trying to move towards a more circular economy, which actually says, no, it's always a resource, it's always valuable. Get value back. It may not be the same thing again. You may not use the plastic bottle here for another plastic bottle. You might use it for something else. Fine. But just make sure you're keeping the resource going around and around and around. That way, I believe, you can get resource consumption, you can get growth, but you're not really overall consuming the resources. We have to minimize the use of virgin resources because they're all going to cost us more and more in the future. And the demand for these things, don't underestimate the demand. It's not just us, of course. We now face, I do a lot of work in China, where I see 1.3 billion people, 150 million of them now middle class, classified as middle class. They are consuming and want to consume more and more. We cannot turn around and tell them, don't consume as much as we did. They won't listen. Why should they? So we have to recognize the fact demand for all these things, and therefore all the resources that are behind them will go up and up and up and up. We've got to change our model. We've got to go from a linear model into a more cyclic model. That's one of the big take-home messages. Also, as I said, decoupling the whole idea of growth from resource consumption. The other point I wanted to make, while I've got time, is around what I call complexity. Because we are making life more and more difficult for ourselves. We all recognize the importance of recycling. We say, oh yeah, we must recycle stuff. Many of us here, I'm sure, are conscientious citizens. We take our empty plastic bottle after it's finished and put it into a plastic recycling container. Yeah, we're doing that more and more, which is great in a way, but what happens to that? Is it really recycled? And the answer is not a lot, no. You talk to the world's biggest waste companies who are desperately trying to get more and more recycled material because policy is forcing them into, new policy by 2025, I think it is, says in the future, packaging material must contain at least 30% recycled plastic, 30% recycled. At the moment, they recycle maybe 10% of what they collect. The stuff that you put in your bins and stuff, maybe about 10% of that might be recycled. So we can't get enough recycled plastic. You pay more now for recycled plastic than virgin plastic. This is a strange situation we come into, where policy is ahead of technology. We need the technology to improve. Now, why can't you recycle a lot of the plastic that we throw away at the moment? And the answer is because of complexity, because we've made things so complicated. We put so many different things into everything. All these things contain not just one chemical, but a lot of different chemicals. Each of those chemicals has its own resource issue, its own processing issue, its own potentially waste issue as well. I brought one example, which I raided from my kitchen today. Sorry, the kitchen, the bathroom. And it's called a gentle polish, it's polish as opposed to Polish, sorry, polish body scrub. It's a shower gel, but with a posh name. The thing about it is, it typifies what I'm trying to get the point across here, because it's one of the few consumer products where you can't actually read what's in it. You think about how many consumer products you buy, which actually lists all the chemicals. Interesting. I have no idea why they do for some things and not for others. And this particular product's got in it, I reckon, about 25 different chemicals. And I've seen them as high as 50. And I'm a chemist, and I have no idea what most of them are there for. I can recognize that the first one calls it aqua. We call water, actually. So we have water. The next one, sodium lauryl sulfate, is the surfactant. That's the thing that cleans you. Then after that, it gets into more obscure things. There's some nice limonene, prop Q Avtar later. Limonene is one of the few natural components in there, natural extract from citrus, as you hear earlier, and that gives it a nice smell. That's quite nice. And there are other things in there. I can understand maybe stabilizing. I can understand maybe giving the right gel properties so when you open the bottle, it'll pour out. So there are certain things that I recognize, but 20, 30, 40, 50 different chemicals, I have no idea. Now, I'm not suggesting recycling the gel is going to be easy, but the point is that this applies to many other things. My mobile phone, my precious app, I love my iPhone, always have done, but it's now got over half the periodic table, more than 60 different elements in there. I mean, the previous generations had half that, a quarter of that. Why are we making things so complicated? You imagine then trying to recycle those things when everything is so complicated. So it makes it really, really difficult. Even the plastic, so the plastic bottle this thing's in. So eventually this will hopefully go to a plastic recycling facility. But it probably will get rejected, like 90% of the plastic at the moment, because it's so complicated. This is not just one polymer. It's not just one polymer made, admittedly, from petroleum. It's probably a mixture of polymers and certainly a mixture of other chemicals, because they put into the plastic things like plasticizers to make it more flexible. Not so much in this, but certainly in the furniture you're sitting on, there will be flame retardants, good safety precaution, it could make sense. There will be colorants, this is slightly tinted. There'll be stabilizers, there'll be several chemicals inside this plastic. So when I try and recycle this plastic, I'm likely to release all those additives. And those additives, in many cases, are not very nice. There's no PVC recycling now in Europe because the one company in Italy doing this had to stop because they were releasing a banned substance when they tried to recycle PVC. This is lack of joined-up policy. The substance I'm talking about, by the way, is phthalates. Phthalates are toxic. They shouldn't be used, but they have been used. You try and recycle old PVC, you release toxic phthalates. The same applies for polyurethane. Polyurethane is commonly used in all sorts of different things. Polyurethane contains flame retardants, which are now banned and recognized to be toxic. So you can't recycle it. So what do we do with all this stuff? We have all this stuff. We all try to be good and collect the things together, but we can't do anything with it because it's full of things that So we've made, as I said, we've made things far too complicated. So another message I'd like to leave with you is complexity, I believe, is the enemy of sustainability. We must get into the mindset that actually simple is good. Simplicity is fantastic, We should learn from nature, which often does things remarkably simply, and make our products simpler, because then, of course, you address the end-of-life issues as well. Now, how can we deal with all these challenges? Because fundamentally using a non-renewable feedstock, making ever more complicated products, using processes which can be quite hazardous and quite awkward to make products designed only for a landfill site. So it's a fantastic opportunity, a real new industrial revolution, I would say. It's opening up. And this is, of course, where we let's start at the very beginning of the future green value chains. Not starting with petroleum, but starting with something which actually at the moment we don't really want, we call a waste. And that's where I can cue my colleague Avtar to come in and start talking about some of the work we're doing here, and is, I think, multiplying around the world in terms of just seizing an opportunity here for this industrial revolution and starting with a waste stream. Over to you, sir.
James, thank you. I'm going to use your prop.
You're going to have a
terrific.
shower?
Absolutely.
I'll never see that again now.
Ladies and gentlemen, sort of my opening line always is, our minds are like parachutes. They work best when open. And I say that to all of my research students because that is the starting point if we are to change our behaviour. Okay? If we want to take positive action, okay, we've got to work with an open mind. Now, this is my world. Okay? Simple, humble, orange. Okay? So, first of all, has anyone tried to eat an orange without peeling it? Yeah, you're just too smart, okay? Too sensible. I'll tell you why. I've sort of mentioned that in a moment. But this is our planet, ladies and gentlemen. Okay? View this orange as planet Earth. It's not shrinking. It's not getting any bigger. Okay? This is what we inhabit. And this is the problem of today because our planet is under severe stress. James has mentioned a resource stress. Okay? We are consuming too much resource. We're consuming too much material. We are generating too much waste. Why is that happening? Okay? Because the population of our planet is increasing. Okay? We're here, 7.5 billion, rising to 10 billion. Where do we put 10 billion people on this resource, on this planet? Okay. The implications of having 10 billion people, okay, how do we provide affordable, clean water, sanitation, healthcare, food, nutrition, all of those global grand challenges that have now been identified under the banner of 17 Sustainable Development Goals. So how do we achieve those? But if you just view it from this prop, okay, that's a starting point. Okay. Within those challenges, okay, the United Nations set out, we've got the 5 Ps within that. We've got planet, population, people, poverty, prosperity. Okay? So all of those are interconnected, and that's why it's great to have everyone in the room today. I think I was saying to Joan, this is one of the rare occasions where we've got an open lecture that's open to everyone. Everyone's got a vested interest here, which is fantastic. So what's the area of research that I work on? I work on what's known as unavoidable food waste. So, orange, bananas. Okay. Has anyone tried to eat a banana without peeling it? So that's what I mean by an unavoidable food waste. Okay. So, an orange, to get to the orange, and the reason why I borrowed James's prop, it just got me thinking, so we've not rehearsed this in any way. Why is it that this labels all the ingredients, whereas this doesn't? And probably there are more ingredients in here than there are in this bottle. We never even think about what's actually inside here, apart from what we want, which is actually the orange. So as I'm peeling, okay, I am now generating unavoidable food waste. And anyone in the room who's from business school, economics, management, when you go to buy an orange, assume it costs 10 pence, okay, you are now throwing 3 pence of what you've purchased into the bin, okay, and that's not good business sense. Okay, so this should normally, you're either going to compost this, okay, or it goes straight into the bin. And as I've been peeling, already I can smell, okay, that characteristic distinctive smell of oranges, orange essence or limonene. So some of that limonene has gone into James's prop, which is the shower gel. Limonene is actually a fantastic both smell, so it's used by the perfume and fragrance industry, but also it's a fantastic household cleaner. So if anyone uses any of those orange spray bottles, okay, I was going to say Mr. Muscle, we'll just say Muscle, because it doesn't matter whether it's Mr. or Miss or whatever. One of those cleaners, okay, and you get that sort of orange colour and it's enriched with orange oil. It's this material now off here. So that is a value product that we've not even realised because we're just interested in the juicy segments of orange. So here's my sort of first prop, and this is what we do in the centre. If you go out into the exhibition area, I've got colleagues from green chemistry, and you'll see a microwave. And basically that is our piece of kit to take out orange oil from orange peel. So essentially we take orange peel, put it in a microwave, and out comes this lovely bottle, okay, of orange oil. This is limonene inside here. And you're going to say to me, Avtar, you've pulled the fast one on us again, and it's just water in here. Okay? So let me just show you something nice that we can do with limonene, which is slightly different to putting it into shampoo bottles. Okay? So one of the other problems that the planet suffers from at the moment is this horrible problem of plastic waste or polymer waste. Okay? And this particular plastic or polymer in my hand is polystyrene. Okay? We absolutely hate this stuff because this is lightweight, it's static, it causes a problem. It's not very dense, it occupies loads and loads of space. Okay? Now, limonene, when I said it's a fantastic cleaner, it's a fantastic detergent, it likes to dissolve things. So here's a problem that we currently face, okay? Here's an opportunity that I've extracted from my orange peel, and I'm going to drop the piece of polystyrene into my orange oil. Okay? And I'm going to leave that there for a while, okay? Because in a moment you'll probably go, oh, where's it gone? Okay? And there's the answer. Okay? So limonene is a fantastic solvent, okay, that we throw away, but it's a solvent that can be used to partially, okay, not fully solve, to partially solve another waste problem. So what we're doing is that the polystyrene is dissolving inside the limonene. Okay? It's not breaking it down, it's just dissolving inside there. So essentially what we're doing, we're now beginning to concentrate this huge waste problem, which is visible, clearly evident, okay, and we're just basically concentrating and reducing it down into this sort of concentrated solution. So that's already happening in Japan. There are lorries that go from office to office, and inside the lorry, okay, is a huge vat of orange oil, and they pick up polystyrene office waste, and they put it into the back of the lorries, and they're concentrating. Okay, what happens to it afterwards? It's not being recycled because we want to get rid of polystyrene. It is actually then going off for incineration. It has a very, very high energy value, both the oil, but also when it's mixed with polystyrene. So that's my first sort of prop. So we've taken out the oil, okay? That's from the front side. But on the back side, we have the pith, okay, this sort of white area here. And that for us is also a value proposition. Okay? So we remove the pith, and in particular, from the pith, we take out what's known as pectin. Okay, so this is a bottle of pectin. So pectin is widely used in jam making and jellies, but pectin is actually a rheology or viscosity modifier. So pectin's used in a lot of food ingredients. So I'm very, very keen that the materials that we recover from food waste should actually go back for nutritional purposes. So that's something that I sort of strongly aspire to. We need to feed the world first and foremost before making sort of fancy goods and articles. So my limonene actually goes back into food flavours, into yogurts, etc. Okay. My pectin goes back into fat-free foods. So, for example, Hellmann's mayonnaise, okay, to provide the thickening properties of fat-free Hellmann mayonnaise, you can add pectin to make it more viscous and gel-like and to get all those sorts of taste properties, the mouthfeel that's really important. Then what we're left with is essentially a jar of what was orange peel, but the orange peel now has had the oil removed. Okay? The orange peel has had the pectin removed, and this is what we call depectinated orange peel residue. It's just de-oiled, depectinated residue. And we aspire to having zero waste. Okay? So this is not the end of our story here. We then take this material and we further process it into this white powder that upside down, okay, I'll move it around that way, okay. That just says MFC 120, okay, the 120 is not important. The important part is the MFC. MFC stands for microfibrillated cellulose. Now, microfibrillated cellulose is one of the best hydrogels, okay, known in the industry. So hydrogel is a material that absorbs water. Okay? And when I go back to the orange, and I said, well, why didn't I think of that in the first place? Because what's the peel actually doing? The peel, if you keep your mind open, okay, the peel is just a giant Pampers nappy for essentially water. That's what orange segments are. Okay? So this is retaining water. So it's this material now that we make into what we call MFC, and we make thick gel. So as an example, what would a thick gel like? Give you an example. Just think of wallpaper paste, okay, or starch and water, and you're gelling something. So MFC, this microfibrillated cellulose, now again is going back into the food industry as a material that's providing new food, and we're feeding the world. So as I sort of finish, coming up to time, I'm just going to take you back. There you go, that was the limonene bottle. And there was a fairly large chunk of polystyrene that went into there. Okay, and that's disappeared. So there's no magic tricks. I usually wear a half-sleeve shirt, so there's nothing up my sleeve. Okay, and I'm just going to see if this works. I like to finish with a bang, and there will be a bang, hopefully. I just need a volunteer to come out. The volunteer has been carefully chosen. I want to choose the largest balloon.
Okay, the biggest balloon.
Yeah. Okay, so not sure whether this works. This is live. This is orange peel. Orange peel can dissolve polystyrene. You've just seen that. Orange peel is a fantastic cleaner. Okay. Can orange peel now get rid of another problem, which is balloon waste, or can it? Can you explode a balloon just with orange peel? So you just want to hold it up. If you don't like loud bangs, you might want to do that. I'm hyping this up, and it probably won't work, but let's just try. Okay. Thank you. So I think it's really important. This is what James has taught me. Okay, James has taught me two key principles. Okay, one, green chemistry never stops. Okay, and green chemistry is not a theoretical subject. Green chemistry has to work. Okay, so this, you may view it as a gimmick. Okay, but this shows the importance of what we're doing with capturing value from waste. And in terms of climate strike, I disagree with the word strike. I think today is actually more about climate action, climate innovation, climate enterprise, climate positivity. And on that note, thank you very much. Thank you.
So we promised half an hour. We promised half an hour of amazingness, and I think we got that. I'll never look at an orange in the same way, and I now know what James keeps in his bathroom, which is an added bonus I wasn't expecting. So thank you all very, very much for coming along. We do a lot of public engagement in this university, and I firmly believe that we should all, as organisations, not only as individuals, act like parachutes. And so there'll be a lot more of this in the coming months in terms of rolling out a whole series of events around the aspects of climate change and climate sustainability. So thank you very much for taking the time. It's a very sunny day. You could have been out absorbing the last heat of the sun for this year probably, or in St Helens Square where there are lots of protesters. So I really want to thank you all for coming along. Keep an eye out for more events coming up, but do as well go and have a look at the stalls in the atrium just now. And thank you to, if anybody's in the room who contributed to those stalls, thank you so much for doing that. I think it's mostly staff and students who are in the room, but if there's anyone else from outside our community, thank you. And again, keep an eye on our events threads on social media and sign up to our events alerts, because there'll be lots more events on this topic in the coming months. So thank you again, particularly to James and Avtar, and for their action-packed talk. Thank you.